We are here at the Photokina 2012 at the Carl-Ziess booth, talking to Mr. Bertram Hollinger. Hello.
Hello.
He is the international sales and customer support for Carl-Ziess. And we have a few questions for you about the new products that you introduced here, and a few general questions about lenses in general. Let's start with something which is actually more general. How much can you make a lens smaller if you move from full frame to APS-C to say micro four thirds? If you take the same lens, of course.
Yeah, that's not so easy to answer. Of course, it depends mainly on the focal length, and of course for the desires, what performance would you like to have, especially at full aperture. So if you keep the performance at the same level with the same focal length, with an APS-C size lens, it's about 20 to 30% less in volume you can reach compared to a full frame lens.
And if you go to a micro four thirds or a smaller sensor, say?
It mainly depends on the focal length. Okay. Standard focal length, it's quite easy to make a standard optical design, a planar design, which you can make quite smaller, maybe 30-40% smaller for micro four thirds, with a really wide angle lens with good performance, where you need a retrofocus type, although you have the short back focal distance, the short flange focal distance of mirrorless systems. The difference in size and weight wouldn't be that much.
Okay. Let's move to the new 55 1.4 millimeter that we have, I think, here. It's a prototype still, right?
Yes, this is a prototype lens. We plan to introduce it next year in autumn.
Okay.
So these are the first lenses of this type, and we want to prove that you can get a performance at full aperture that wasn't possible so far with a standard lens. And combined with high resolution full frame cameras, you will reach a performance that is similar or even identical to a medium format systems.
Basically, one of the questions that we got for this lens, it's based on a Destington design rather than a planar or Sona, which is more typical for 50 millimeter or standard focal length. Why is that?
So a typical planar type, so this is a planar one, okay, a little bit different, difficult to compare it, but the basic planar design only contains 6 lens elements. And if you want to improve performance extremely, especially at full aperture, it was not possible to reach it with a classical planar design. So a completely new optical design had to be developed. This lens contains parts of a distagon design and also parts of a planar design. It's very unusual. So, of course, we had the question how we will name this lens, and we decided to make it distagon because it's a little bit more similar to a classical distagon than to a classical planar lens.
The front element is 82 millimeter, right?
Yeah.
This is the largest front element that I know of for a standard lens design. What advantages does it give you to have such a large front element?
Yeah, it has different reasons. Well, the main reason, of course, is you will get a very unique illumination across the complete image field of a full-frame sensor. When you increase the entrance pupil like this with a large front lens element, and you know all our distagon types also have a large front lens element. This allows to flatten with the spherical elements inside, especially in the front part. This allows to flatten the image field in the focal plane, so that you can get crisp, sharp images from the center to the edges, even at full aperture.
Okay. Basically, when you said before, I think, that this lens can actually reach the quality of medium format in a full frame lens. What exactly did you mean? I mean, what quality does medium format gives you in terms of lenses that a full frame doesn't?
High resolution, high contrast across the complete image field, even when you use it wide open. The big advantage of such systems, of course, is it's still smaller and more lightweight than a medium format system, and you can use higher speed lenses. So this lens allows to get the same contrast sharpness like a medium format lens with less f-stop.
Okay. You introduced, I think, a few days ago, maybe the 135mm for Canon and Nikon. Here, this is the lens. What else basically are you planning for Nikon and Canon and Nikon line of lenses from Zeiss maybe next year?
Well, it's still a little bit too early to talk about detailed plans. Of course, we are working intensively on new lenses. We plan to spread out the line of focal lengths we already have, so there's still room for longer focal lengths, for instance, and we have lots of requests for additional macro lenses, additional to our 2 macro lenses we already have.
Maybe I will ask you a different question. The last time we talked in Photokina 2010, 2 years ago, I asked you if there is a chance that we will see autofocus in Nikon and Canon lenses from Zeiss. And I think that you answered that at least partially this is due to licensing and other issues. Is there a chance that something will change in this respect and we will see autofocus lenses from
So it's still similar to the things we discussed 2 years ago. Autofocus requires a close relationship to the camera manufacturer. We have this with our partner Sony.
Yeah.
And so we still concentrate on autofocus lenses only for the Sony system. Okay. For other cameras, Canon and Nikon, we will stay with the manual focus lenses for the next future.
Okay. What about stabilizer for Canon and Nikon? I mean, Sony doesn't need it because it has a stabilizer in the body, but for Canon and Nikon, is it possible to add a stabilizer in the body even without an autofocus system?
Yeah, would be possible, of course. As long as you have the electronic contacts to the camera. Of course, the lens requires more power. But the reason why we do not make such stabilized lenses at the moment is you have to reduce your expectations regarding image quality a little bit. Because the movable lens elements are always a little bit critical, you cannot really get an extremely stable performance for the lens. So we do not plan to make this within the next time.
Okay. You introduced basically a new line of mirrorless lenses. Maybe you can tell us a bit about them?
So these are just mock-ups, no functional lenses so far. We will start with 3 focal lengths, starting with the 2.8 12mm super wide angle lens. The next one is the planar 1.8 32mm. And the third one will be a 2.8 50mm macro lens. So, and all of those lenses will be available for APS-C size mirrorless camera system. We start with lenses for the Fuji X mount, like this, and for the Sony E mount for Sony Nex cameras.
The 50mm is going to be a macro lens?
Yes.
And
right.
it's going to be 1 to 2 magnification?
So that's not fixed at the moment. We do not have a prototype so far, and these lenses are planned to be introduced next year in spring or summer, and I'm sure within the next time we can give out more details about those lenses.
We tested the new 135mm that we see here in the booth, and we saw that you used a different focusing screen. Can you maybe say a few things about it?
Yeah, of course, accurate focusing is always essential if you want to have extremely good results, especially when you use those lenses wide open. That's what they are mentioned for. Also with the 1.455 or with the Apo sonar, and with the normal focusing screens that are built in the today's autofocus cameras, they are not really suited for manual focusing. They are very bright, but mainly for autofocus use only. So we recommend to exchange the focusing screen, and fortunately some third-party suppliers offer such screens, Bright Screen or Cat's Eye. And so in all of our demo cameras we build in those screens. We strongly recommend to use them because it's much easier to focus precisely with them.
Yes, it's what...
You tried it out?
Yeah. Final question, again, general question. How complicated will it be to create a lens, a zoom lens, which has a 2x zoom with an aperture, say, of 2.0 instead of 2.0. For example, instead of 70 to 200 millimeter, 2.8 to make something like 50 to 100, 2.0.
As long as you stay for the same sensor format for full frame camera. The question is not only for physical reasons, how much the diameter of the focus of the entrance pupil has to increase. The big question is the requirements for the performance. So the performance is much higher for the optical design if you want to make a faster lens, especially a complicated zoom lens, than with a little bit slower zoom lens. So the lens would be extremely bulky and a heavyweight, and for photography, for still photography, there are limitations, you know. Nearly no user wants to use a lens of this focal length he just can use with a tripod. So I do not think that it will be possible to make such a high-speed zoom lens in the next future.
Okay, thank you very much.